start the recording. Hello YouTube. Stream started like 1 hour ago. I had like I was doing this basically. Like just one quick fix to my Nix config, and then I got lost in there. But we can close this because I'm not gonna touch my fish config anymore. And I created day 12, and now finally close my fish stuff, refresh, and go check out day 12. Okay, so with your submarines, subterranean subsystems subsisting suboptimally, the only way you're getting out of this cave anytime soon is by finding a path yourself. Ooh, finding a path. Not just a path. The only way to know if you've found the best path is to find all of them. Unfortunately, the sensors are still mostly... fortunately, the sensors are still mostly working. And so you build a rough map of the remaining caves, your puzzle input. For example... Oh my god, is this a graph? This is a graph. Okay, so start. A, B, A, C, A, B is... Okay, so this is a list of how all the caves are connected. You start in the cave named start, and your destination is the cave named end. An entry like BD means that cave B is connected to cave D. That is, you can move between them. So the above cave system roughly looks like this. Why is A uppercase? I'm wondering. Okay, let's keep on reading. So your goal is to find the number of distinct paths that start at start, end at end, and don't visit small caves more than once. Oh, there we go. Don't visit small caves more than once. There are two types of caves: big caves, written in uppercase like A, and small caves, written in lowercase like B. It would be a waste of time to visit any small cave more than once, but big caves are large enough that it might be worth visiting them multiple times. Why? But, well, okay. So all paths you should visit small caves at most once, and can visit big caves any number of times. Given the rules, there are 10 paths through this example cave system. Okay. Note that in this cave system, cave D is never visited in any path, because it doesn't lead anywhere. To do so, cave B would need to be visited twice. Yes, once on the way and on the way back. And since cave B is small, this is not allowed. Here's a slightly larger example. DC end, HN start, start KJ, DC start, DCN, blah blah blah. So wait, so start now appears on the right side. The writing path through it are as follows. Start HN, DC, HN, end. Okay, finally, this even larger example has 226 paths through it. How many paths through this cave system are there that visit the small caves at most once? And there's our puzzle input. Okay, so I think this one is worth starting with this input and see if that we get that right before anything else. So let's copy everything correctly this time. And let's make it work. Okay, so what do we need to do? We need to have we need to build a graph, I guess. And then we need some kind of like path first search system to build our paths, all paths. Okay, this one is gonna be annoying. It's been way too long since I've done anything like this. Let's start. Oh, I'm stealing some code. No more Nix shell. I've seen enough Nix shell for today. So we're gonna need an allocator. I think definitely yes. I don't think we're gonna need a matrix, do we? Well, maybe. I mean, we need to represent the graph. How are we going to represent it? Like a matrix or a list of nodes that you can reach from one place to the other? I think we can be lazy with lists. A bit of code where the challenge is more remembering some angles and actually knowing how to code. I mean, they're puzzly stuff, so I guess like they bring teasers. I don't know. I guess it's fine that they're like this. It's just that it's been so long. It's been so long. And I don't know. I feel like I'm somewhat less interested in this type of problems because I mean, I don't want to come up with excuses. I guess I should be able to solve them easily, but I don't know, the interesting problems, the problems that I find interesting nowadays are different in structure, and so these ones are like completely entirely in the part of my brain that doesn't care much about them anymore. In any case, so we don't need position. Also, I think there's a layer of laziness where I don't want to work hard because it's not useful, right? You find a solution to a puzzle and that's it. Like I would definitely be willing to put effort into this kind of logic if I was building something that actually at the end of the day was going to be useful thanks to this algorithm, but that's not the case. So I don't know, that takes away some win from myself, but it's fine. So I would say we can be super lazy and maybe build a hash map, and we put as key one end and as value the other. The problem is that these are all, so this is an undirected graph, right? Or rather, if you will, every arrow is bidirectional. So like, just like start leads to B, B leads to start also. Although, well, let me say that with the uppercase letters, it's always true. With the lowercase letter, is this always true? So because lowercase letters have the problem where you don't want to go through them multiple times, right? So maybe a trick for doing that is that lowercase letters, you only put them to the left side, while uppercase letters, you put them both sides. It's not exactly what the exercise was saying, but I wonder if this trick is going to basically encode the same constraints. So let me think about this. Also, wait, let me maybe look at the other example, the trickier one. So this one has and on the right side. So we do start, and then we need to find start towards something. So we can find start towards DC, starts towards SN. Okay, starts towards DC. Once we're in DC, we can do DC HN. Do we need to have HN DC? Yes, because DC could actually connect to end. Like this is not the case in here. Oh no, actually it does. DC does connect to end. So a valid path is gonna be start HN, HN DC, DC end. or start DC, DCHN. Oh, no, this one is not going to work, because if we do start DC and we do DCHN, then we cannot do HN DC. But okay, I think that my idea of not adding lowercase letters twice is not going to work. And I'm going to fall back to the safer solution, to the safer approach, where we put all of these entries both sides. And so we basically make an entry where start is the key, A is the value, and another one where A is the key and start is the value. In the case of start is kind of dumb, but for all these other intermediate ones it seems reasonable. And then we need to keep like a set of the small caves that we've already visited, so that we don't try to visit them again. And there's also another question about loops, but I think that loops basically exist if a big cave leads to another big cave eventually. So like in this example, there's only one big cave. If there's two different big caves, one leading into another, that's a problem. But in all these examples, there's only one big cave. This one has two big caves. So if these two big caves lead to one into another, oh, but you know what? They would have to be directly connected. As long as they're not directly connected, we're good. Because even if they are connected through a small cave, you can't go through them. You cannot go through that small cave more than once. A-B can't exist, as that would mean infinite paths. Yeah, I mean, well, that's not how I interpret it. I mean, yes, I agree that that's in a way of seeing the problem. I would argue that maybe if that was the case, then maybe it would be your job to avoid looping forever and just realize that that's one path. But I guess that's okay. So if you go for the more academic definition, then yes, it's infinite path. I don't know. I'm looking for curveballs that the exercise could be throwing at me. But I think it's easy, right? Because you can inspect that visually. Like I can open my input and see, is there any uppercase stuff leading directly into another? No. So I'm good. So I don't have to worry about identifying these loops. And because they have to be direct connections. If they are indirect connections, it's still not going to be a problem. Okay, so my graph is going to be, I think, a hash map. A string hash map. Nice. Although, wait a second, string hash map, huh? I'm not sure if I want a string hash map. It's definitely gonna be a hash map with string as keys, but the string hash map is doing like useful stuff when you normally want strings, while my strings are a bit different. I think string hash map copies the strings, but I'm not sure. So whatever. Let's do it here. Okay. So how do we tokenize this input? We need to tokenize on dashes and new lines, right? And we have one node, dash, second node, new line, and that's how it's gonna be. So for, I don't know why, while I hit on next, if there is one, it's gonna be a node. Also, as I said, we need to split on new lines and dash, no commas. So if we're gonna get node and or let's call it node A, and then node B is going to be another it.next. Dot question mark, because we can be sure that it's going to be there. Okay, so we have the two nodes, and we put both in a hash map, I guess. So also, why is this lowercase g? So g dot, I don't remember the signature, so we need to go find in the source code how hash maps are, and it's gonna be a bit annoying because I think it has its own file in here. So hash map, yeah, because hash map has a bunch of implementations that use one another, and everything depends on hash map. So like string hash map is it's a normal hash map, but where there are like some defaults. So the keys are strings. Also, I need to put const also in my value strings. They're also const. And there's this string context thing, and there's like a bunch of string context. Basically, it's your hashing and equality functions, and they are tailored for strings. So string uses hash map, and hash map uses hash map unmanaged. So we need to go inside hash map unmanaged to see the signature. It's a bit annoying, but I think maybe we can guess. Pub function insert add put. There we go. This is the public key interface. So capacity put no clobber, put some capacity, fetch put. Okay, we can just use put key value, and that's it. Okay, easy. So this needs to be a constant slice, then put what? Node A, node B. I think you need to try this because you can allocate, and then try g.put node B, node A. Okay, so we put both. We do this for everything. We get to the end, and now we start building paths. So I need, I guess, what? An array list? I think I need two array lists, right? I think I need one array list that I use to build one path, and then one array list that I use to collect all paths. Although, do I really need to collect them? Because if I do my algorithm correctly, I don't think I don't need to remember the old ones. I just need to enumerate them. So I don't need memory about that. So that should be fine. Cap Anex, thank you for the follow and welcome to the stream. So I think I'll go with the solution where I don't try to remember them. I just need to count them, right? It only wants counts for now. So var path total path count. It's gonna be 0. Then what's the end condition? Okay. We basically need to have knowledge of everything that we still need to explore, and we need to pick from there. Let's take a look at Wikipedia and what it suggests for a nice search algo. Also, does it need to be, I think I want depth first, right? It just made me realize my deduplicating of found paths was totally needless. I'm sorry. I'm going on Wikipedia to learn about how to do depth first search. So yeah, each of us has their own issues, I guess. Also, you were probably doing it like at high speed. I'm not. I'm taking my sweet time and still. Because I think that if you do depth first search, you don't need that, right? The way you implement it immediately, you only have to worry about loops, maybe. Actually, I don't know. Well, you have to account for that in any case. But in our case, we're good, so that's not a problem. Okay, so show me some beautiful pseudocode. Oh god. Recursive implementation of depth first search. So procedure DFS GV is label V as discovered for all directed edges from V to W that are in G adjacent edges. Do if vertex W is not labeled as discovered, then recursively call DFS. Maybe we should not do recursive in Zig. Maybe we should do the while loop implementation. Although, then everything that we gain is a stack in userland. So maybe I do want the recursive version. I think we can, I mean, okay, let me look at this. This is not that deep. I think we can afford to have this many frames on the stack. So let's actually go recursive. Fuck it. So for all the letter edges from V and W that are in G adjacent edges, do blah blah blah. It's not labeled, recursively call. And basically we want to do this, and if the second node that we get is end, we know that we found a full path. We add one and we return. And if there are instead no options to continue, then we know we got into a dead end. That's cool. Okay, so let's do this. So this is gonna be there's this label as discovered that's like, this is one funny line that says, oh yeah, just label it discovered. Now it depends on how you implement it though, because I think there are a few different ways of doing that. So let's do function DFS, I guess. G is my graph, so it's gonna be one of these bad boys. And then we have DFS wants a starting node. Oh, well, let's call it cave. Let's call it current cave. Which is a name. And what does it return? Well, I think our recursive function wants to return numbers, so we return usize, I guess. We want to return counts. So label this node as discovered. How do we label this node as discovered? Also, wait, the knowledge that nodes have been discovered is global. But even then, wait, question mark, is it really global? It's not global, because when we pop and we're doing a path, when we come back, the path segment that we didn't care, the path segment that we just used when we come back, needs to be labeled undiscovered because we can find then another path that goes somewhere else, but then that goes back to one of the nodes that we just used. So we need, as we return from a recursive call, we need to also undo that change, which means that this label as use stuff is local knowledge. But we also doing, if something is not labeled as discovered, means that we need to also have upper knowledge. Do we? Let me think about this. Maybe we don't need that, but the problem is that we need to know that we cannot go through small caves more than once, and that's really important. And in a sense, that's our label as used. So sorry. So I think we do need to have. I think we need to know. So we need to somehow inherit this from the recursive call. Yeah, we need to have this from the recursive call. Also, I think we can cheat because I think we can put this stuff on the stack maybe. Oh, but if we put a lot of stuff on the stack, it's recursive. I already hate recursive functions. Oh my god. Yeah, that tea. I took a sip of tea that owned me. Let me get more. So right now I'm basically worried. I understand the algorithm at a high level, but now I'm kind of trying to understand the implications of what I'm doing with the recursive call from a perspective of the memory that I'm going to use. And this is like a dimension that I never worried about because I did this stuff in university. But when you do it in university, you care about setting correctly the bottom case of your recursive function. You care about setting right your recursive equation thingy stuff, and nobody ever gives a shit about where does the memory go. So now I'm trying to understand how I want to do this, because do I want to heap allocate on each call? Do we want to reserve a bit of local memory? But then how do I refer to my upper stacks? Do I pass down a pointer? Do we do a linked list? It's a linked list. It was a linked list all along. It's a linked list. I think it's a linked list. So I don't know if I just had a flash of genius or if I'm a complete moron. And no, I'm not. So I'm not talking about the graph itself. The graph itself for me, it's a hash map. So yeah, I'm good. But the question is, how do I mark down nodes that I've already visited in a nice way? And I think the nicest way is a linked list where the nodes are on the stack. Let me double check if that makes sense, because that might be not correct. Because there is a for loop. So for each, for all the directed edges that go from V to whatever W we want, if vertex W is not labeled as discovered, then you call DFS on it. Yeah. Isn't there a variable size array in Zig? Yes, there are, definitely. I could heap allocate, but I'm trying to find a nice solution from a memory perspective. So I'm doing the recursive call. Oh, Anti66, thank you for the raid. Hello everyone. So I'm trying to, I visited is either an array of bools or set of vertices. Yes, but there are so many ways to represent this stuff, and as we return from those functions, we need to undo what we did, right? Although actually, wait, I could have just a global set of these, and I could just unmark stuff as I return from the function. Actually, unmarking stuff is probably the best solution. Okay, I think I learned something interesting. At the end of the day, this is probably not going to be useful for this algorithm. So in this case, we can just have an array of bools or a set of vertices or whatever, and we share it across all calls, and we add something to that set when we start, and before returning, we remove from it. But that implies that we are able to do side effects to that shared part. So so that's fine. But in a context where you cannot do this, maybe because you're doing parallel stuff, then it's so nice. You can put one of these items on your stack. So here's the idea. I'm not gonna do it, but here's the idea. Again, this is a part of the problem space that doesn't really matter much, I guess, for AOC, but it's something that I find interesting now that I'm using these. So the idea is basically you do this const. So you have a linked list type of thing, like const. I don't know, used node or something, and it's gonna be struct node or like value, I guess, or name. Let's call it name. So name, I don't know if you even care about the name, but let's say that you do it, or actually yes, you do, because you need to test equality. So it's gonna be a const u8, and then you have prev, which is a pointer to use node, a constant pointer. And then you can do this const used equals use node of prev. Also, it's an optional. Okay, so use node is gonna be not name equals current cave, prev equals prev, and you pass prev as an argument. So the idea is that when you do the recursive call, you do DFS. So, well, you have your for loop that gives you nodes, I guess, or something, right? Maybe it's not a for loop, but you have your iteration on all the nodes, and then you do DFS on. You call DFS on G and your new cave or whatever, and then as prev you pass in a pointer to used. So the to use, and in the code where you need to check if something is used, so the code that checks or visited, whatever. So what is it? Skip if already visited, ignore if already visited. Then basically you can do while prev well, now you have to do like var p equals prev while p, and then every iteration you do p equals p.prev, and then you do optional unpacking, and then in here you check. So call this prev, I guess. Oh no, you can't call it prev. Okay, you need to call it something else. Let's go pp. So then you can do if pp.name. Got around, have fun. Thank you. If pp.name equals so I'm not being precise, sorry, this is basically pseudocode. Equals and then you do something else. But the idea is this becomes a linked list, and the nodes are all a single stack element, like a single variable on a function frame. And since you're recursing, each function frame only needs to hold space for one of these things. And and you pass down knowledge of where to find the previous node through this argument, and then by chasing these chain of pointers backwards. And this way you can test if the thing was already visited at one point. And I think this is a trick, like this general trick of putting a node of a linked list in your stack frame so that you don't need to allocate, so that you need to do weird stuff, is used by the event loop in a bunch of places in Zig. I think there might be also other uses, but one use that I know of that I've already encountered is a way of doing evented IO without needing heap allocation, because you can do this amazing trick where you basically store the async frame inside the function frame. And I think that's nice, right? So I'm not going to do this, but I think the good property of this is that I'm going to change this with a shared object that everybody, well, a shared struct that every call of the FS shares, and I'm going to apply side effects to it, so I'm going to mutate it. And it works because my function calls are happening in a nice order that makes these changes have meaning. But this works if you do parallelized stuff. Like you could, you would change the algorithm from recursive like this to something different, right? You would need to do some kind of parallelization. Maybe it would have to become breadth first instead of depth first, or some kind of mix of that. But then this could run in parallel, and they don't rely on a global share object that cannot have a consistent meaning across stuff running in parallel. They all rely on local information based on their own call chain, on their own individual call chains. So I think this is a technique that's useful to know. Not for today though, apparently. So know this even, I guess. Maybe. Or maybe yes, but not of use node. No need to parallelize this problem. Yeah. In this implementation, no. But I realized that. So I didn't immediately think of sharing one thing and just mutating it and undoing the mutations as I return from the function. So I originally thought of doing the nodes on the stack thing, and yeah, then I realized that it wasn't really important. But I was saying it could be useful when you need to parallelize stuff, because at that point when you're parallelizing stuff, you cannot have a shared thingy. Okay. So let's make the shared thingy. The shared thingy needs to be what? We need to look at the hash map, and I think the hash map will contain twice the number of nodes that we have in the system. So basically we only need to make what? An array list along half that, and then we push and pop, and that's gonna be our path, I guess. That's pretty much it. So let's see. very interesting approach. Thanks for explaining. No worries. Yeah, it was fun. It's more on an engineering thing, right? It's less of a brain teaser than this. It's more about it's when you start caring about where the memory comes from, which is lately the thing that I have been exploring with Zig. Is there a good way to debug and or profile Zig programs on Mac? You can use LLDB on Mac. So I have to be honest with you. So what you're seeing here is a Linux virtual machine on a Mac computer, because I kind of got tired of having to deal with macOS, because there are some annoying things. Like I believe that if you want to be able to debug stuff, no, it's not debugging. You can debug without having to do anything, but if you want to run, I think it's called dtrus on Mac. Dtrus is the equivalent of strace on Linux. Basically, you run a program to dtrus, and it tells you all the syscall that the application did. And to be able to use dtrus, I think you need to reboot the computer in restore mode and disable some security features from there. Otherwise, it won't work. Which is super annoying. We were easily lied to. Well, I'm sorry, I'm not. So if I wouldn't say I'm a proud Mac user, but I'm definitely a proud non-100% Linux user, because to me, having Linux in a virtual machine is actually pretty cool. Okay, virtual machines suck because it's virtualized. You wouldn't like it to be non-virtualized, but NixOS is not bad, actually. It's pretty efficient. Well, I guess it's not just Nix, it's Linux in general. Less bloated than Mac, but GUI apps on Mac are just better. I'm sorry. I don't want to use LibreOffice. I don't want to use all the janky calendar stuff on Linux. I need proper productivity tools, and Mac gives me those. Like I have occasionally to open doc files from Microsoft Office. It's part of the job. I can't avoid it. Also, I think that having Linux on a virtual machine allows me to experiment more. I'm not doing it now, so this is X11 with i3, but I would like to switch to Wayland and River. Also because River is written in Zig, and also because I don't like how I have to manually garbage collect empty nodes in i3. It's weird. So I want to try that out, but then you switch to Wayland and now your screen share on Discord doesn't work. You have trouble, I don't know, screen sharing on other tools. But if it's in a virtual machine, I don't care, right? If it's in a virtual machine, I can do whatever I want in there. I use Discord from my host machine and I screen share the virtual machine window. So, and same also when I go to conferences and I have to connect to a projector, there's not gonna be a Linux moment where now my Linux doesn't recognize the projector and it's kind of weird. So I think this is a very interesting compromise, especially if you do this on a laptop. Like the M1 chips are pretty good, and I got a M1 MacBook Air, and it's amazing. It's tiny, lightweight, it's pretty fast, and for traveling is, in my opinion, one of the best laptops you can get. So you would advise not using Mac to debug Zig? It depends on what you're doing. Like if you just want to debug, like if you seriously, the question is, I just need to debug, just use LLDB. It's gonna work. But I'm using Zig now so much that I just wanted to get rid of all the what's it called, all the friction there, and so I ended up saying, you know what, I just kind of want to try out go back to Zig again for that. But it's doable. So for Zig, you don't need anything special. Like LLDB is gonna work, and you have LLDB on your system. So okay, I think you need to have Xcode maybe, but like it's not hard to get LLVM on your system. That's my point. Sorry, LLDB. There's also other tools for profiling that Apple has. I'm not an expert. There's somebody in Discord that knows this way better than me. But I think there's like a perf stat thingy, maybe somewhere. I have no idea where though. Maybe it's in here. I don't see it. Activity monitor, no. So there's a performance thing that can be used like it's a graphical Mac tool, and I've seen people use it, but I don't know the details. So I don't know. I think that the bare metal programming is better on Linux than it is on Mac nowadays. That's my general impression. Will LDB also work with stage 2? Oh yes, absolutely. So Zig itself. So the thing is, Zig will not use. Oh, okay, I see your point. Like you make a what happens if you make an application that's not compiled through LVM? Will LDB still work? Yes, it will still work because debuggers work on Dwarf debug information, and on Windows they use EDB. So there's like this debug information stuff that's like kind of standardized between debuggers. Like you can use GDB, by the way, also to debug Linux, to debug Zig executables. The problem is that GDB doesn't work on Mac. So it's not like GDB doesn't work with Zig. It works. It just doesn't work on Mac. So this is standard, and you're good. You can also use Valgrind. You can use, as I said, strace. Like the normal tooling that you would use to debug C, C++, Rust, also works with Zig. I think the worst that you can get is that maybe one of these debuggers might not fully understand, like might not easily understand, I don't know, like Zig strings, how to print them nicely. There are maybe some workarounds to that. I don't know precisely what the state of this stuff is. But let's say, aside from minor issues that you might encounter, which I would assume, which I'm fairly confident will eventually be streamlined, you should not have any problem. The biggest problem in debugging Zig on Mac is Mac, not Zig. So a few years ago, I built a QNX-based embedded application, including FPGA code, in a Linux virtual machine in VirtualBox in an iMac. You use the tools you need to get the job done. Nice. Though running Vivado in a virtual machine is not recommended. I don't know what Vivado is, but I'm guessing if it's a FPGA emulator, I can imagine it becoming slow once you're like that deep into emulation. But that's the beauty of this setup. Like I have a GUI in here, but I'm mostly using like, I'm using a text editor and like terminals 99% of the time. Like the main reason to have a GUI in your Linux stuff for me is so that I can flex my fancy setup, which I actually stole from somebody else, but from Mitchell Hashimoto. But also in here I can run Firefox, and so I can like do OAuth login stuff, like workflows that require you to open a browser. And occasionally, I don't know, I want to indulge in Sublime instead of using Vim. I can do it because I have a GUI stuff. Also, it's fundamental, I guess, for Borg. So here you can see that Borg is able to display emotes, but that's a TUI application. The way it works is that it's running inside Kitty, and Kitty is a terminal emulator that has a nice graphic protocol. And with the graphic protocol of Kitty, I can print Twitch emotes. Does it make sense to also use Xcode with LLDB, or is that in fact the same thing? No, it's not the same thing. LLDB is a standalone executable. I don't know if when you debug stuff with Xcode, whether you're using LLDB under the covers or not. Seriously, no idea how that works. But like for writing Zig, I would personally recommend to stay away from Xcode. Like if you do love Xcode, then go for it, but otherwise you really don't need it. We have that issue with Rust. Debugging tends to work with any debugger, but it doesn't understand all types properly. Yeah. Yep. I think that some work could be done to make the user experience of using those debuggers better, but I don't know. Maybe we'll get there one day. So let's see. Xcode gives a nice front end compared to the terminal for LLDB. There's also some other TUI GUIs. I don't know. They're kind of jank to me. My impression is that these debuggers are slightly too janky than what I would like them to be, and so adding a GUI on top of them always gives me the impression that that just makes them even more janky. So I end up not wanting it. But I don't know. I think like the best GUI that I want is just like a source code window where you see a bit of source code and the line where you're stopping at. That's it. I think everything else is source of jankiness. Or at least, I don't know. I remember trying a while ago to use a few different graphical interfaces for GDB, and I ended up not being happy with any of them. It says on the LLDB website, LLDB is the default debugger in Xcode on macOS. There you go. So that's what Xcode is using under the covers. Okay. So we were doing the DFS stuff, right? So how do we... Here's the thing. We need to find out... we need to find out how many nodes are there, right? So we need to build the path. So at the end of the day, the place where we keep track of whether a node were used or not could simply be the path that we're building. The problem is it's gonna be a linear scan. Maybe you can do better than a linear scan every single time. But even then, like, we don't have that many nodes, so maybe just doing a linear scan is not the end of the world. So I think I'm gonna try to be lazy and just do the linear scan and not care about anything. So here's what I'm gonna do. I'm going to do var path buff, and it's gonna be a std array list of what? An array list of strings. And then we pass this to DFS. So we can do total count is gonna be the result of calling DFS on G start there's no prev, but there's path buff, which is going to be a pointer to this array list. Actually, I don't know, maybe you can copy the array list struct. I have no idea if it's self-referential or not, but who cares? Just pass a pointer, it's fine. There we go. And now we have to do the recursion, right? Let me think. We could... This is... So... do I really care about this? So, do we even care about having somewhere the path itself? So I said that I was fine with the linear scan, but now it's making me uncomfortable because I don't even need to have anywhere printed out what the path is. I could add a print statement in the recursive stuff, although this could be useful for debugging, you know? Because then we could print the path every time we reach the end, instead of having to print everything every time, which might lead to dead ends also. But no, I think that the recursive printing could be already good enough. Okay, so you know what? No array list. No array list. No array list. We're gonna make another hash map, I guess. Or what? Yeah, let's make another hash map. I changed my mind. We could also modify the elements in here, but oh, whatever. It's a hash map with no values, so it's a set basically. So visited set. Visited set. Okay, we have a visited set. Now, the algo was label the current node as visited. So visited set dot add current cave. And then the fur visited set dot remove current cave. So we need to undo what we did as we return back. Then let's go back to the algo. I'm just gonna do one by one what it does mindlessly. So we find all the edges that start from V. Oh, wait a second. This cannot be a hash map like this. Because if the key already exists, oh god, so annoying. So I was kind of saying, oh yeah, hash map is gonna be good enough, but it's not good enough, right? Because Sublime Text and Unregistered name a more iconic duo. Yeah, you know, the funny thing is that I do have a license for Sublime. I'm just too lazy to input it. I should do it one day. Although I'm kind of thinking maybe I should add it to my Nix config. So oh man. Yeah, right. So basically, if we do this, we'll find out that unfortunately we override stuff basically. So we need to do something different. We need to have values. We need to actually build a proper adjacency list. So let's make this an std of array list of slices. There we go. And here's how it works. We get the two nodes. We get the node, which is, I think, get or put. So it's gonna be g.get or put. Let's look at the signature of get or put. If key exists, this function cannot fail. If there is an existing item with key, then the result entry pointers point to it. Maybe I don't want get or put. Maybe I just want get. No, I think it's get, but when there's so if key exists, hashmap interfaces in Z are kind of annoying. If there is an existing item with key, then the result entry pointers point to it, and if found existing is true. Otherwise, puts a new item with undefined value, and the entry pointers point to it. Okay. Caller should then initialize the value, but not the key. So it's fine. Get or put. We need to do it twice. So for so how should I do this? Should I just make... Ah, I can do this. Right. Oh, so nice tuples. Not A, not B, not B, not A. Hopefully this will work. Let's call it KV, maybe. Okay, so for each key value pair, Epic Blarg, thank you for follow. We need to do this. We try to find the entry. Oh, okay, let's call it entry. And it's gonna get or put what? KV element number 0 or key. And so if not entry dot, what's it called? Also there's a try, entry dot found existing. So if this wasn't found, it means that it created a new one that we need to initialize, a new value that we need to initialize. Actually, just one thing that we need to do. So we need to do entry dot value dot star. Actually not. It's entry dot value dot init. We need to init the array list. And that's it. Okay, at this point, we can do entry.value.append kv1, the value. And we do this twice, so by swapping the roles of these two. So now we're building the hash map correctly, I think, hopefully. So now we get the other nodes. So for, well, let's see if we even get any other nodes. So const entry is going to be g.get or null, I think. Get or null current cave. Get the current cave. And it's gonna be an optional. So let's see, where's get or null? Get or put adapted, get or put, get or put. Get adapted. Oh no, get gives us optionals already. Okay, so it's implied that it's an optional. So get cave, or else if it's null, well, if it's null, we just return, where there's nothing that we have to do. But if we do find an entry, then for entry.value.items, cave. So for each of these caves, what do? We just call DFS on them. I think that's the algo also on Wikipedia, just to double check, but yeah, we just call DFS on it. Oh, if it's not labeled as discovered. How do we find out if it's not visited? If it's not in the visited set? So, okay, if oh, and we are returning new size, so we need to return a count. So we return 0. And so for each of those, we need to, oh, it's gonna be a bit more complicated. So we need to accumulate stuff, I think. Var paths found is a useId. So returning this freaking value is so useless. It's so much better to have a freaking global value and just assign to it. I'm so tempted to do that. You know what? I actually I love side effects. I don't like functional anymore. I just want side effects everywhere. Look at this global variable. Look at these global variables. You can't stop me. Nobody can stop me. Haha. Global variables everywhere. You're lucky I need to initialize. Actually, you know what? I could even put this as a global variable so that you don't need to pass it around anymore. Same with G. You know, I'm so tempted to do this. Nice. So we only care about the current cave. We can add the visited set. Yes. So as I was saying, if we don't find any matching place where to go, we return. If we do find places where to go, we're gonna get a bunch of caves, and now we don't need about the internal bookkeeping because we do side effects, yes. And so if the cave is not in the visited set, if not visited set dot contains cave, maybe. Let's go find out. It's an hash map of the visited set, so pub function contains. There we go. Yes, contains. So if it contains, if it's not contains, then we call DFS on it. Else nothing. That's it. That's what we do. Oh, so much simpler. Maybe we can put new lines to be nice. What do you think, the format? Error, expected opening parentheses found, exclamation point, line 39. That's fair. We are missing the bottom of this thing though. So the bottom is that we get here, or actually even before that, what we need to do is if current cave is end, we need to do something different though. std.mem not equal u8. If I do just equal, it's gonna compare slice instances, which is not really going to work. So u8 current cave and end. If it's the end, then we want to do paths count. We want to do paths count plus equals 1, and then we want to return. I think that's it. So we have the bottom case. So we init the visited set. This couldn't go up here. Are we initting the hash map? No, so we need to also init the hash map. Oh, it's up here, the code. So init this. We init G, we init the visited set. We tokenize. We need to call the FS on start. Are we trying stuff in here? I think this is a try. So we need to error out. Here we try the FS. Here we try the FS. And then we std.debug to print. Almost one crucial thing is missing. Okay. Okay, so let's see. Right, there's one crucial thing missing. I agree, and that is that we don't put on the visited set uppercase letters. Maybe we should put it in there and do something else. No, we just don't put it. We just don't put them there. So we need to do. How do we do this? How do we do this? How do we do this? Oh, I know how to cheat. So let's look at the final input also. The uppercase ones are all uppercase, right? The lowercase ones are all lowercase. So I'm just gonna look at the first letter and test the first letter so that I don't have to like string compare over and over everything. Here's the problem. I cannot do this. I cannot do if uppercase then do these things, because this will make the defer run as I exit the if block, and that's unfortunate. So I need to embed the if test inside here. So I'll show you now. So this is not gonna work what I'm doing now. If current cave 0 is greater or equal than A, then we do the one above, but we don't do the one below. And in the one below, we need to basically reapply the test. Oh. Come on, visitor. That's unfortunate. Maybe I can remove these to make it nicer. Is it nicer like this? I don't know, maybe. Okay, so with this we should be good. Maybe I should also add some debug stuff so that I can print the paths, so I can test that everything works nice. How am I gonna do this? I'm going to print current cave basically. std dot debug dot print maybe like this. And then if we got to end, we print. No, actually, so let's put it before everything, and if it's the end, then we just print a new line, or maybe a couple. Okay, well, let's see if this builds. User declare identifier start. Right. It's start. Expected one argument, found two. I'm pretty sure a string hash map. Do I not use string hash map anywhere else? I think it does. It does require an allocator. Oh, but it doesn't require self. It returns self. Okay, so basically it's like this: g equals this.init. I need to call it on the type because that returns the instance. Okay, I guess the same applies to this too. Unable to evaluate constant expression. Okay, so this is a problem. Or maybe not a big problem, but so I'm kind of abusing tuples here. Lloyd, thank you for the follow. Also, Epic Blarg. No, I think I thanked you already. So I can do inline for, and I think it will work, but it's still, I think this is less typed than I would like it to be. Because this is basically, like, this could all be runtime slices. For some reason, Z doesn't realize that, and it thinks that it needs to make them all tuples. Let's see. But that seems to make it happy. So, no member code found existing. Okay, that's fair. Line 19. No member name value instruct. Oh yeah, because it's value pointer. It's value underscore PTR. Right. Expected one argument, found two. Oh, guess what? I think it's the same problem. So it's value pointer dot star equals array list blah 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 dot init. Oof, error is ignored. Please consider using try, catch, or if. Enter value dot append. That's fair. Non-member named add in struct hash map. Because it's put. It's put. And I think it's, but when we do put, we also need to specify the value, which is void, but we need to put the void value there. Also, I think I need a pattern break, so sorry for the suspense. I'll be right back shortly. No banning, AFK. No. Let's make it 5 minutes. Yeah, it's this. I'll be right back. Yeah, and I was also muted. Yeah, timer was too short, yeah. Maybe I should add to it like I should let it go negative. And I start printing negative time. So that you know how much late you were. I don't know if it's a good idea. Okay. So I think I was about to compile this and see if it compiles now. Incompatible types, bool and void. Incompatible types, bool and void, line 45. Okay, let's go take a look. Line 45. What? I guess it's missing an else branch. Yes, it is, but oh, you're right. So you're right. I think that's what's happening. So the if statement doesn't have a block. It immediately has an expression. So this becomes an expression-y if that returns a boolean from this, but there's no else branch. So basically we need to make this, we can do this. Almost. We can do this. Almost. Why is it not working? Expect a semicolon found const. It's this. Okay. So at this point, you know what? I could just simply open this. Oh, and then I need to close it too. There we go. Super ugly, but whatever. Also, so the fact that this returns something, should we put a safety test? We should not put a safety test because there's no point. We are not putting uppercase letters. We're putting lowercase stuff. We are just undoing what we just did, so should be fine. Okay, next error. Expression value is ignored. Oh, right. So we didn't solve it. Okay, so you know what? I think there's a way of solving this. Like this. So since we need to throw away the result anyway, we do this. This is the expression inside if now. And since this is an assignment, this becomes a void expression, I think. I think you inverted the if condition. You are right. You are right. Oh, shit. What's first in the ASCII table? I don't remember. Now I'm actually having... I don't remember which is which. Like, which comes first. Weird stuff. Numbers. Uppercase letters, then lowercase letters. So it has to be... Uppercase letters are lower than A. Right, thank you. So this means that lowercase stuff is lower than uppercase A. Right. No! Invalid left-hand assignment, hand side to assignment. Oh, damn it. So we still don't solve it. Oh, because it thinks that all of this is the left hand of the assignment. Okay, fine. Then, non-member value, non-member named value, I think you want greater or equal than A. Oh, you're right, because greater than, wait, what was it? Greater than, no, lower than uppercase A doesn't work. It has to be, oh my god. Yes, greater or equal than lowercase a. Oh, yeah. Yeah, thank you. You're babysitting me. Yep, now it's correct. So here value doesn't exist, right? The value is a value pointer, but we can still use dot notation on it. Next, oh, non-name value pointer, instruct array list aligned. Oh, because get gives us, oh right, get doesn't give us an entry, just gives us value straight up. So it's value dot items. Can I resolve the inferred error set? Okay, so here's another funny problem. So Zig has this very nice feature where it automatically understands the error set of a function based on all the potential errors that it can toss around by using try and other stuff. But when it's recursive, Zig doesn't really know what to do yet in the stage 1 implementation. So it doesn't know how to automatically produce the error set. So at this point, if you're doing like nice engineering, you basically need to pin down the error set explicitly somewhere. So you define, you do const dfs error, or maybe it should be dfs error. Yeah, I think it should be like this, like dfs error equals error, and then you enumerate all the errors in here one by one that can be. Which is nice, because also if you like, it's not bad to have an explicit error set written down somewhere. It's useful for complex stuff. But in this case, we can basically, let's say, type erase the errors. So we can do any error, and we say, you know what, it's fine if you're not able to tell me which errors are gonna happen. Segmentation fault. Segmentation fault here, I think, means that this is buggy. So let's go away from this tuple stuff and let's make it easier. Let's make it like this. So this is an array. Let's be explicit with the types. It's an array of two consuates. Is this what it is? Yay. I think this is metaprogramming stuff that's kind of buggy. There we go. So it gives me result 10. Start A, C, A, B, A, and the end, and oh, this is not printing start, I think. Wait a second. Wait, is it at least the correct number? I think it's not even the correct number, is it? Oh yeah, no, it is. A, B, A, C, A. Well, A, C, A, B, A. B, C, A. B, A, C, A. And why is this? Okay, there's something wrong with the way I print. It doesn't print whole path, you're only printing current vertex. I mean, yes, I'm only printing current vertex, but if you print the current vertex every single time and printing the current, it's a depth first. So if you keep printing the current vertex and you end up with printing end, which we do, then you should have printed out a complete path, I think. Only first path will be complete. What happens if you have a path with common initial segments? I mean, my point is that these will all be explored, right? So I'm just printing all of them. I think the only thing that you're not seeing here is the first node, right? You're not seeing start. No, actually you should see start in the beginning. You do see start. Wait, okay, so we start with start. We print start. Here then we go down with all the nodes that are in start. Why don't we always see start and we see new enters? Oh, I see what you're saying. So you're saying we go to the end, we print a new line, and then we start printing other suffixes. Yeah, that's right. That's fair. That's correct. Yes. So we're like doing ABC, blah blah blah, and then I guess there's A, C, A, B, then maybe D end, then maybe A, B end, then A, B. Then this is a segment that, like, this is a suffix that probably starts from here. That's right. I could probably somehow keep track of like how deep we are in the thing, but who cares? So, I mean, the result seems fair. So let's see if the number is, for this one, is gonna turn out correct. So slightly larger example. Let me double check that I copied correctly for Mac. The 19 paths through it are as follows. So let's see. Save. 19. Finally, even larger example. 226. Input. Oops. $4,573. Also, I think that by just removing the prints, this would speed up so much. Like, I think the prints are really bad for this algorithm. So let's not print anything. Well, not for the algorithm, like just for the implementation. Okay, so you have to keep in mind the first time you run the command, it's building it also. The subsequent times it's not building anything, and this is also including how much time it takes for Zig to compile everything. So not bad. It's like it's instant. So cool. Okay, 4573. Are we finally done with the first half? Yay! Part 2. Okay, after reviewing the available paths, you realize that you might have time to visit a single small cave twice. Specifically, big caves can be visited any number of times. A single small cave can be visited at most twice, and the remaining small caves can be visited at most once. However, the caves named start and end can only be visited exactly once each. Once you leave the start cave, you cannot return to it, and once you reach the end cave, the path must end immediately. Now, 36 paths are possible through the 36 paths through the first example above are blah blah blah. Okay, so now we need to implement this more annoying version. Cool. So I'm going to copy what? Maybe I should copy everything. Oh no! Now I'm getting pwned by my own globals. Oh no. I'll copy everything. Well, no, I mean main and DFS, I guess. Why is it not selecting? Okay, selection is so buggy with this. So let's go back and call this DFS1 maybe. Or you know what? This is so annoying that I think I'm just going to modify it in place. Let's not try to do bookkeeping. There's no point. Okay. So we need to add the ability to visit a small cave twice. So var small cave free token. It's like there's or okay, let's call it visited twice. So starts at false. So this is more of the state that we need to keep track of. Hey, Code Monk, hello. Is this part 2? Yes, I just started. Hey, Soap. So why are you not following the stream? Oh, I so wish you were my follower. Thank you. Okay, so how's it going to work? You can visit it twice. So we can do this. Basically, we visit the set. More than not follower. Yeah, that's, I don't know. I know it's weird, right? I think everything else can be the same. The only thing is that now we basically say we kind of want to visit it twice. We can do it like this. Oh, you know what? We can do it. We can maybe do it like this. If the cave is small, if it's a small cave, then if visited twice is false, then we set visited twice to true. Oh shit, then how do we know that we need to set it back to false? I mean, we can do it. We can say that we are the ones who set it false. So you know what? Okay, no, never mind. So I think that visited twice, this is actually a perfect example of something that we should pass around. So visited twice, it's a bool, and we say if the current cave is lowercase, if the current cave is lowercase, then we look at visited twice. Also, we need to make it modifiable. So arguments are constant in Z. So are immutable. So we need to make another one. Twice is visited twice. So if current cave is lowercase, if visited twice is false, then twice then twice equals true, else otherwise we add it to the cave. So basically the first time visited twice is false, we remember that we are going to pass down the knowledge that we already consumed, we already burned our chance, but we don't add the cave. Otherwise, if it was true, then we add the cave. So you know what? We can make this nicer, I guess, right? We can remove this. Okay, this is better, I guess. So if we already visited twice, then too bad, we need to add stuff. Otherwise, we remember it, and now when we call the FS, we pass twice. That's it. And when we start, we pass twice, set to false. Oh, that's nice. And in the first exercise, it's basically the same, just twice starts at true every single time. So like this is a nice way where you can use the same code base twice, right? Flip the yeah. Okay, let's see. Does it build the list? Yes. I don't know. Is this, maybe it just works? Maybe it just works? That's not the answer. Your answer is too low. Also, you know what? I failed to account for one thing. So the fact that it's too low, it's kind of worrying. I also failed to account for something. I need to special case start and end. So let me special case start and end. Actually, I think that I don't need to special case end because the moment we encounter end, we immediately count the path and return, but we need to special case start. How do we special case start? Well, actually, we do it already, right? Because we say, no, we don't do that. We don't do that. I think we need to basically initialize visited set with start in it already. But that should at worst expected free arguments found to, yes, sorry, put start and empty. The problem is that this should lower the count. That's bad. That lowers the count a lot. Okay, so there's clearly something wrong in my logic. There's definitely something wrong in my logic. Okay, let me think again. Start is already assumed to be in the visited set, so we never return to start ever. Then we keep in mind if we already visited twice. If we are in the cave end, we're good. Otherwise, is this a lowercase cave? If it is... Oh, wait. No, okay, so if it is a lowercase cave, and we have already visited something twice, then we have to add it. Otherwise, we don't add it, and we set twice to true. Then either case, when we return back, we remove it. Is this bad? Let me think. How do you know you visited something twice? Oh, wait. Oh, yeah, you're right. The problem in here is that I'm dumb because this is going, because this is going to burn the token like with cave A, but then I get cave B. So I need, yeah, you're right. The problem is that I need to know. So this thing only happens if the cave that I'm trying to it only happens if the cave that I'm trying to add is already there. So I was hoping that I could like solve this by changing here, but I also need to change here, unfortunately. Okay, so if it's a lowercase cave, we need to check. If it's already there, then we flip twice, otherwise we don't. So if visitor set dot contains current cave, if it contains current cave, okay, if it contains current cave already, then we need to check if we have the ability to visit it twice or not. So if it contains current cave, if we visited twice already, then we could just straight up return from this. Actually, we don't even need to do this, right? We don't need to do this. We don't need to do this. We don't need to do this. We can just immediately return. Otherwise, well, it's already in the set, so we don't add it. We don't need to add it, but we continue forward, but we need to set twice to true. And I think this is it. Okay, let me double check this. So if it's a lowercase cave, wait, somewhere I need to add it. So there's something that I'm missing out on. It's an else branch, I guess. Here, where I need to add this or something. Okay, give me a sec. So if it's already in there, and we already consumed our ability to visit something twice, we return. If it's in there, but we haven't visited anything twice, then we know that we consumed our one possibility to do that. If it's not in there, then we can add it and continue as usual. Okay, so this should be better. It doesn't change the number. Okay, so there's still something wrong. Let me think. We are visiting caves. We encounter the ability to go in a new lowercase cave. And also the cave needs not to be started. Here's another problem. Cave really needs to not be started. Because I think we are doing like this could still work. Okay, but that's not the problem right now. Because we are getting a number that needs to increase and it's not increasing at all. So does it have the current cave? We have yet to add the current cave, right? Yes. The only place where we add stuff to the current cave is here. So we're trying to add stuff to the current cave. To the visitor set. If it's already in there, and we have not visited twice already, then we visit twice. And we don't need to put anything because it's already in there. So it's okay that we don't do this. Oh. We cannot remove that willy-nilly. We can only remove if we never have if we are not the ones that switched twice, right? We really cannot remove. Although this should not increase the number of paths, I think. We are restricting our ability to remove stuff. Like this should at best lower the number or rather, like it's either the same or lower. There's something that we're missing that needs to make that number go up, because that's the original number, right? Yes, that's the original number. It hasn't changed. It needs to go up. There needs to be, unless in my case there's no change, but that seems weird. No, in any case, the bigger number was already considered too low, so there's something wrong. There's something more that's wrong. Okay, so we can only remove stuff from the set. You know what? Maybe a count would have helped. Maybe no, it needs to be kind of like this anyway. So we can only remove the cave from the letter if it's lowercase. But we can only remove the cave from the visitor set if it's lowercase and we did not use the twice token in this iteration. If we consumed it in this iteration, then we can't remove the current cave and as we go back. That is fair. Now, why is the number not going up? Because here we are not mirroring, we are not leveraging the fact that we are giving ourselves a chance to visit something twice. So here we are seeing that it's in here. We're saying, well, that's no good. No, we need to say, we need to realize that it's fine if it's in there when we are the ones who have burned the visited twice. Although, wait a second. This doesn't tell us with what ID, with what cave. Oh no, it's the current cave. Wait a second. My brain is burning. Wait a second. I'm close, but not quite there. I'm still kind of confused, but I'm getting close. So how do you... There's some general points that are true, right? So how do you freaking increase that number? By iterating more. And right now, I think the one thing that iterates more, okay, maybe there's some returns, but this seems necessary. This is definitely necessary. Here we are removing less, which is maybe a problem, but that also seems necessary. So it's here. The problem is that I need to not get confused between the current node and all the other nodes. So the problem is that visited twice should not be a bool. Visited twice needs to be an optional string. Yep, it's an optional string, and it needs to, yep, it's an optional string. It starts at null. Because the problem is that here I need to say, I need to check that if that cave, like, I only iterate if the set doesn't contain the cave, or cave is or that cave is my cave that can be visited twice. And that will increase the number of caves, like number of iterations, so that makes sense. That helps us bring the number up. So now let's do the rest of the bookkeeping correctly. So I think now I flipped the reasoning behind visited twice. I think maybe no, like the falsy value was a good one. So let's see. If visited twice is different than null, then return. Otherwise, twice becomes current cave, and we start passing down that, which then we can look at here. Now this is going to be a bitch because how do we do this? How do I say twice equals visited twice? Can I do that? I think yes, I can do equals. No. It's more complicated because visited twice. No, they're all optionals. I think Zig is going to complain because I don't think you can equate stuff like this, but we'll see. Yeah, cannot compare times, optional consuate and optional consuate. Yeah, so I think there's this that I can do. So basically there's an equal implementation STD meta that I think should like try to find you a reasonable comparison. Oh, nice. Okay, so this seems to be fine. The problem is that here visited twice, now it's an optional and it's not always present. So how can I unpack this nicely? I can do or else empty string. If it's null, then this is always going to be false and it's fine. Maybe I could do something like this here too, but I don't know. Oh no, that gives me the same number. It didn't go up. God damn it. It should go up though. I think this is not doing what it needs to do. Also, wait, should this be visited twice or twice? This should be twice. Because, well, it actually I think doesn't matter because we should never find our current cave. Although no, because now, since you can now visit the same cave twice, you can go inside a dead end and immediately get out of it. Oh no. Let me think. No, it's not allowed, is it? Now I'm getting hyper confused. Yeah, this doesn't even make the number increase. Oh, I think I need to simplify this code a little bit because it's becoming a bit too confused. The version of just bool was good enough, it only missed one condition. I'm having trouble seeing this because I think that this is necessary. So when I'm going down, when I'm going deep and I'm looking at caves that I can go inside again, if I did not visit twice, oh, wait. I guess the idea is that if I did not visit twice, I can go in here regardless. I think that's the thing. Right, because I like the thing is preventing from going down, not enabling going down. So if this is not contained or I never visited twice. Okay, let's go back to bool then. I never visited twice. I can go down. Otherwise, if here is already twice, it's this, and also this can go back to being inequality, I guess. Yeah. Ooh, so bad. Okay, let's see. I think there's still something that needs to be done. Extract the type bool found slice. Yes. I think there's still something that needs to be done, maybe. No, this is true. Oof. It does not increase, so there's still something missing. Okay, let's revisit everything from start. If the current cave is a small cave, and we've already visited it, and we've visited everything twice, we just return. If the cave, we already visited it, but we haven't consumed twice, then we set twice to true. Why do we need to set this here? We basically, at this point, we don't need to do this because, oh, it's this. Right, so I think we can simplify some stuff. So, const visited or like present, let's say. If it's present in here, so if it's not present or we did not visit anything twice, then we go down here and we just pass down present, so that when present is true, we pass down true. If present is false, we pass down false. And so here we need to do less stuff. So we now just need to do, let me think. We now just need to do this. Let me see if this simplification makes sense. Also, wait. We only remove going up. Oh, no. I'm getting myself even more confused now. But I want to explore this simplification though. Is this possible, or am I doing something that I should not be doing? So I think this is useful because I think this is a nice simplification, right? I'm saying when I go down, the fact that I consumed my ability to go down twice, it's basically present. When this is false, oh shit, when this is false, we might have visited twice already something, but then this is false at one point, so we cannot just return present. We need to return present or visited twice. Yes. What to do when visited and visited twice, not twice? So because we have visited something twice at one point, then we keep it going down, and now we are looking at something that we haven't visited twice, but we used it in the past, so we cannot, it's a chain. We cannot forget that we visited twice when going down. Then what about this thing? When going up, So the problem is that by moving this down here, now we cannot do this anymore because this happened beforehand. So there's the problem where I don't know whether to put this check when going down or whether to put the check on my own node, and I'm having trouble deciding what should go where. Oh man. So we cannot do this now because here we are not the ones flipping it. So I think this is a problem. This is a problem because it means that I cannot do this then. I don't think that this implication works because then I have no way of expressing this. The problem is that I am going back, and now how do I know if it needs to be removed or not? I guess I can I guess I could move this stuff in here. I could also move this in here and say we remove. That's terrible though. I think I'm going back to the checks above there. So let's undo some changes. Okay. So we are at the current node. The current node was already present and we are about to add it. If we already consumed our ability to visit twice, we cannot add it, so we basically return. If we if the visitor set contains the current node, but we haven't visited twice, then we set twice to true, and going down, we'll set twice to true. If the set does not contain the current node, then we put it there. Then when removing it, we only remove it when can we remove stuff? We can remove stuff always except when visited twice was false and twice became true. When we are in this specific case, because this is how it happens, we had set twice to true and we originally had visited twice to false. This is when we have consumed it. Then down here we grab all the other nodes and we continue if it's not contained or it's visited twice, or we did not visit anything twice. If we did, okay, let's see. Every valid path can visit caves twice independently. This should be also my case because this is recursive. So the concept that I visited something twice is passed down. Hey cryptocode, the concept that I visited the same thing twice is passed down as an argument to my recursive functions. So what ends up happening is that like it's false in the beginning, then it becomes true at one point in the call stack, and it keeps being true downwards. And as we hopefully conclude paths, and then they have the same prefix, then we go up. Once we go past that double use, visited twice goes back to being false because that's the value that you originally have in the calls up there. 7. Okay, so that said, there's clearly something wrong in my code, without a doubt. But you remove them from visited set. Oh, you're right. It's the opposite, right? We can remove them when we are not in this case. Sorry. Okay, this is fair. I did the opposite of what I wanted to do, right? We can remove them always except when we did this. But that doesn't make our number increase at all. Visited set is global to all recursions. Okay, let me think. Visited set is global to all recursions. Yes. But that's not a problem because the recursions don't happen in parallel, they happen one after another. So I do modify visited set as a form of global state. But with this, what happens is that I add stuff to the visited set, then I defer its removal. Defer runs at the end of this function call. So you can imagine that this if is basically put after everything, like on line 66, inside DFS, but on line 66. So I call down, and start A, C, A, end, start B, C, B, end. So if start has a connection to A, we do it, we add A, we see that we can go from A to C, we do it, we add C, we see we can go from C to A. A is in the set, that's not good. But we did not visit twice anything yet. Visit twice is still false. We go down. We are in current node A. We see that it's contained, but visited twice is false. We set it to true. And we continue. We find end, we count the path, and we start returning back. We pop. We remove here, so this is the second A. So that's the case where this happened. So we don't remove anything. We return from that function. We get here, but it's C now. It's not the case where we consume the token. And so we do remove C. Then we go up. We remove A. And then we go up. Or we remove A, we go back to start, and then we find ideally B. Well, B is the second element in this while loop, and then we keep going down again. So in my mind, this seems to work correctly with this. Clearly there is a problem, but like in terms of general architecture, this seems fine. So Maybe I should really start printing the behavior, or even just debugging it. I should run this in the debugger, maybe. That would help. Maybe that would really help. So let me see if I remember how to do this stuff. Zig build XZ. Definitely not release fast. We stay in debug mode. Then we do LLDB main. That's it. Then where do we want our breakpoint? I think we want our breakpoint. Also, maybe we want a simpler input. Let's go back to like the most simple input. Also, I don't even know what it says for this for the most simple input. Let me exit from this for a moment. Zig run main.zig. Result 10. Is it correct that it gives 10 for the original input? No. Let me think of one where you can do. Oh, maybe yes. Maybe the original input is too small. So let's see. This is, there are 36 possible paths through the example above here. Okay, so it's the one with A, B, C, and A. Oh wait, is this the first one? Yes, it's the first one. Okay, so the first one becomes 36. Why? So start A, B, A, B, A, and let's see. Start A, B, and right. That's possible. Okay, so let's see what we see when doing this. Oh, you know what? Before debugging, let's just print and see if the prints make any sense. Like if they at least seem reasonable. So it finds start A, C, A, B, A, and fine. Then suffix D, and A, C, A, B, A, C, A. Yeah, I don't see the letters being used twice. Like, I'm not sure if these suffixes are good. But it is missing definitely the ability to use the same letter twice. Why am I not going through B and then from A back to B? Like, these should always allow me, like, there's no point where I'm saying, okay, I'm going to A, maybe this is it, but there should be so many more. So it seems like we have trouble returning to caves that we actually visited. So maybe it's this stupid thing that it's like these conditions that are wrong. So let me try to make the conditions more explicit. Maybe that will help me. So instead of doing this, let's do it like this. Let's do var consume let's call it visiting twice, maybe. Oh my god, there's visited twice, and then what's a good name for this? Visiting twice now is false. And then we set visiting twice now to true. And then basically we're saying that we do this if we are not visiting twice now. The difference is that this originally was a modifiable version of visited twice. Now it's instead, the concept is slightly different. It's just the concept whether we are visiting stuff now. So this simplifies this thing here. And here basically we are saying that we want to go down and it has to be either that we are visiting twice now, or we already were visiting twice. We already visited twice before. Okay, so now they are like separate concepts and I need to order them, but I think it's a bit more clear. So why are we not even considering... Why are we not considering B again? Why are we discarding it? Because we get to A and uppercase A, and uppercase A will have the option to go to B again. But we're ignoring it. Why? Why are we ignoring it? Are we returning here to match? No, because yes, visited set will contain B already, but we haven't visited twice yet. So we don't return. Then I guess here the condition is wrong. So okay, let me think about this. It doesn't seem like that, but that has to be the case. So we look at all the caves and we say, if the visited set contains them, if it does not contain them, then we're good. If it does contain them, and we have not visited twice, then we're good. I think this is slightly wrong, but a cave doesn't lead to itself. So since caves don't lead to themselves directly, it's fine which one we use. I'm having trouble seeing the problem. Then there's, because we should be able to... My god, this has to be the dumbest, the most moronic error possible, and I'm not seeing it. You're so close. Yeah. Let me think. So other places where it's possible for me to make dumb mistakes. So I think this is the hotspot. It's like a double negated thing with an or in the middle. So you know what? By the power given to me by the Morgan, I'm gonna flip this freaking condition around. So if the visited set contains the cave and we've already visited twice, then we want to continue. Else we want to try DFS. Let me check. I think I need a semicolon here. Wait, that's not enough. What do you want from me? Oh, it says finished. Oh, that's just how it indents things automatically. Okay. Maybe we can, instead of having a semicolon here, just have a normal curly brace. Okay, so let's see if this makes sense. And at this point, I think we don't need the else. We don't need this. We can save. If the cave is the visited set contains the cave, and we've already visited something twice, we cannot go there back again. Otherwise, we do it, we go down, and we remember that the fact that we visited something twice is whether we visited it in the past or we started visiting it now. I think it's debugger time. There's no way. So about doing better prints. How do I do better prints? I can do better prints by printing the set, I guess. So you know what? I didn't want to print the set, but here's a funny thing about the set. I think the set underneath is actually stable, so we can print it. I think the set has a baking array. I don't know what's the nice way of printing an array. You would need to construct a list of vertices to printable path. Well, my visited thing kind of does. Oh, but it doesn't mention things that we have visited twice. It's still incomplete, right? Yeah, it's close. It's closer, but the set should be basically sorted because of how the hash map is implemented. Visit doesn't have the order. It definitely does have the order. I mean, you might say that it doesn't have the order because it's a hash map, and hash map usually don't have order. But these hash maps, I believe, do have the order. Maybe I'm wrong, but I think they do. So you know what? Here's what we can do. I mean, the order in which they were visited. Why doesn't it? We add to it as we go down. So like, we start, then we, I don't know, let's say that it's A, B, C, end. We add A, we add start, then we go down, we add A, then we add B, then we add C, then we get end, and if at end I print the visited set, it's gonna give me the current state of the set, which is basically every node except the end. And as I go, and if I print it at this point, and then I go up, some things get removed, I go down again in another path, let's say, and it should work. Again, that depends on the implementation detail that the hash map is ordered internally, which is not always the case. So, what I'm thinking, also, it's funny because we could actually not care about the current cave being lowercase. We could just try to remove stuff, uppercase. Oh, but here's a problem though. The order is correct, but uppercase caves never show up in here. So that is indeed a problem. So, okay, let's build a path. So var path is this, or rather it's of this type. It's undefined. Then here we also initiate the path. Should I do it like this? No. Maybe I should not put start in the beginning. Maybe that's the problem. So we start from the node start. Should I put it already in the path? Maybe I should, but if I do this, it means that I should not put the current node in the path. Wait, the first call is gonna start with start in here. I think it's fine. So we put the current node inside. Here where we were printing it, we just, instead of printing it, oops. we append it. We append the current cave, and if you are at the end, we print every element of the array list and the new lines. So for path, hello Megan, cave, std.debug.print. Don't forget to remove current cave. Yes, that's gonna be easy. So debug.print. Something like this. String cave. Couple new lines, and we're good. The problem is that this is gonna end up printing. So the problem, okay, with this approach is that we just are going to print let me think. With this we're going to print the path, but you know what, I think we should print the path. I think we should not only print the path at the end, but we should also print because this is going to print the path only at the end on the successful case. I think we should also print the path as it gets built. Should you remove path items? Yes, that's what I'm doing now. So I append it. I will remove it at the end. So this is basically, oh, I cannot put it in a block, but I really think we should have fun the fair. Easy. I'm really starting to think that maybe we should really have like fun fn the fair. So that you can have the further runs at the end of the function, and you can put it inside a block, and you don't go crazy with about that. You don't go insane. So try path append. Current cave, we will remove it at the end. We print the current path as we are building it, and then 2 new lines every single time. And that basically will show us that we are not considering certain paths. No member name len instruct. Oh, that's a good point because it's path, not items. Yes. Okay, so we start with start, then A, then C, then A, then B, then A, then end. Well, okay, and that's fair. Then we do B and D. That doesn't lead to anything. Then B and. Then we do this one, which is fair. Then we are done with C being here, apparently. So we go to A, then B, then BA, BAC, BAC. So these are all fair. But we are simply not considering B when we should do. So this debug isn't really helping much because the problem is that I'm failing at considering twice the elements. So the only, at this point, I think the only solution is considering cave contains twice. So it's gonna be cave this. I'm gonna call it twice. I don't care. Okay, this is gonna give more interesting diagnostics. So start, considering A, it's contained? No. Did we do anything twice? No, okay. Considering start, contains true, twice true. Fuck. That's the problem. The goddamn start, right. I forgot to properly special case start in here, and the stupid start was hogging all the double stuff. Although even then, even if start is hogging the double tokens, they should at worst artificially increase the number. So that's not just it. But let's solve this at least. So we should not be considering start twice or any more than once. So how do we do this? Let's say if cave is not start, or rather if it is start, std mem visit twice can happen at any point in the path. Yes. So if it's start or this, we continue. So if the cave is start, we always freaking ignore it. We never do anything about it. Otherwise, you know what? Let's even simplify this even further. Like this, I think. Okay, so if it's start, we continue. If it's a cave that we've already seen and we already visited something twice, then we continue. Okay, so this should start from hogging the token, the retry. Now let's see. So consider it start, but it's a start, so we never do. Why is it twice true already? Why is it twice true already? Oh my god. Twice is immediately true because I put start right away in the beginning. I'm so stupid. This is how I was thinking of accounting for start. But that's a horrible idea. That's what's messing everything up. Okay, let's try again. Oh my god, how long is this input now? 36. What do you know? God damn it. The start, so adding the start in the beginning caused it to always hog the twice retry thing every single time. Since it was right at the top, we could never consume it anywhere else. And that was what was driving me insane. So dumb. Such. Oh my god, I closed my browser. Can I have my old sessions, please? Can we like Command Z, please? Recently reopen last closed window. Thank you. That stupid thing ruined my life. Control A, Control V, Control Save. That's the stupid thing that ruined my life. So path, I don't want path anymore. I don't care about path anymore. I don't want to maintain path anymore. I don't want to print it anymore. I don't want this. Maybe I'm gonna comment them. I don't know. They're not even that useful. Printing in the path is really not useful because it's not showing you your decision making. What ended up what ended up solving the case for me was seeing that visiting twice now would flip at one point. No, sorry, the visited twice would flip at one point for seemingly no reason. And the seemingly no reason was the first freaking iteration because of this stupid line that I put up here and I forgot about. Okay, so do we print anything else? Do we even care about this? You know what? Here's the funny thing. Right now, at this point, we don't even care about this at all. Oh no, maybe we should because... Yes, no, we should. Because we need to account for start somewhere. Okay, path. Where is it that we are using path? Oh, here we are initializing it, right? Wasn't the last number too high, I think? I'm worried. Is this number too big? No, it's the right answer. Woof! First try, yes. Holy shit, first try. I did not expect to finish first try. Lessons learned today. So today we learned Fish has better syntax than Bash for sure. That's nice. I think that's all we learned. I don't know. I think nobody learned anything from exercise 12. No, okay, jokes aside, I think I originally started with like some good ideas, aside from the fact that this is a simple depth first search and I'm so rusty that I didn't figure out right away what to do. But then the problem was in the second phase that I had very muddy ideas on how to account for start. And there's always this problem where you need to have a clear mind on whether you want to do things on your current node or where selecting for the second node. And a lot of things can like shift from one place to the next, except for certain cases where they cannot. Like this visiting twice now is important because we need, since we are using the logic where we are going back up the stack to clean stuff up, we need to keep in here, in this function frame, knowledge on when it is the right time for us to not pop the node because we are the ones making use of the twice token. And so that was important. And after that, it was just a matter of realizing the stupid thing that I did. Oh well. Thank you everyone for the congratulations. Oh man, that was definitely not supposed to be this tedious. Because the problem is that I was trying to go through the tiny errors that I made, like this one, not noticing that when we are going up, we cannot always remove the node. Sometimes whenever we don't add it, we don't remove it. That's something that we need to make sure of. And I have to be honest, I think that having had fun defer would have helped me. Because I could have done this, right? I could have done fun defer, visited set of this. I could have done this. If fun defer was a thing, I could have more easily said, you know what? I'm only removing stuff if I was the one that put it in here. But we don't have fun defer. Maybe this is an argument in favor of having fun defer. Maybe the implementation details of fun defer make it a stupid thing anyway. This is interesting though. I think it's a genuinely interesting use case. And if you ever wondered why is Go, well, fun defer, by the way, is the semantic that Go has for defer. Like all defers in Go behave like this. And sometimes that's not what you want, because sometimes you want to put a defer inside like a while loop and it's pretty clean, and in Go it's not going to work the way you want it to. But maybe the better answer is to have both. It's true that fun defer has definitely less use than defer, because fun defer, it's useful for the cases where you only want to defer stuff that's the result of nested complication. You know what? I also think that I made the mistake of readapting the old code. And by readapting the old code, I already had the defer down here. And so I didn't think about it much. If I had rewritten this code by hand, I would have realized that I put the put here, and then I would need to free stuff. But if the put is inside here, the free has to be also inside here. So it means that I need to replicate the condition outside here. So I think I should have realized it, but the implementation is still kind of complicated. No, it's not. But that's my point, is that it's a semantic that maybe it's occasionally useful. Like in this case, fun defer would have been very useful, because basically I'm only doing put under these two conditions, right? And then I want to defer the cleanup. The problem is that one bug that I left in here was that originally I didn't have this. So I had a cleanup that was running also when I didn't put stuff in here, and that was wrong. And it's a bug that remained because given how defer works in Zig, I'm unable to defer inside a nested scope. I have to put defer at the upper scope, but if I had fun defer, I could have just written this and that's it. It works. But then I don't know the implementations at the machine code level. So I think it would be nice to have like a fun defer thing, maybe. I don't know. But today definitely was a case where this was a problem. Then, what else did we learn and encounter? Oh, nothing much. I think that was it. It's nice to be able to cheat with globals and side effects. When you have to do everything functional, it's annoying, or rather, it makes the expression of stuff a little bit more annoying. Like, the reality is that in my original design, I intended to carry the paths count as the return value, but then that means that you need to do a bunch of like partial accumulations, because you need to sum up recursively everything. And it's like, why are you doing all of these when you could just do simple increments and not have to make sure you do proper bookkeeping in your stuff? ASCII is lower exists. Oh, that's nice. Although, is lower going to be this, or is it going to be a more complicated solution? Because this is also hacky a little bit. Like this. In any case, can you remove any error now, or is it still required? It's still required because DFS is recursive and returns errors. So right now Zig doesn't know how to handle this problem. I think it's solvable, and I think stage 2 should be able at one point to do that. Oh, it's specifically okay. So it does a slightly more complex and more correct version of what it was doing. Okay, well, good to know. Anything else that's interesting about this code? I really can't think about anything else. Also, making this a proper runtime type helped solve a compiler bug, but I think stage 2 should be able to handle 2 nested tuples. Also, for people that are like not exactly clear on the difference, tuples are like structs where like you can put in a tuple different types. Like you can do a tuple with like foo and 5 in it, and it works. But that works because this is a comp time only value that behind the scenes becomes a struct that has a field called 0, which is a slice, and a field called 1, which is a 5. And tuples are nice because they can be used with for, or more precisely, they can be used with inline for, which is basically a for that gets unrolled at compile time. So it becomes not the same instruction with a backwards jump, but it becomes 2 operations. They get basically, if you can think of it as they get expanded at compile time. And so this could have been an inline loop that basically, in a sense, copy pastes these 3 lines 3 times. Like the performance characteristics, like the layout of the binary changes, but who cares? The problem is that, the compiler had trouble with it. Stage 1 compiler, that's what it is. But also second problem is, that's one point. Second point is, that said, this syntax can also coerce to proper runtime values. So if it happens that, for example, these are both numbers, so the types have to be homogeneous if you want to make an array or a slice out of it, right? But if you want to make this a 2 array of, I don't know, usize, then this will work too. So here, this tuple syntax is not going to make these 2 things tuples. It's going to make these 2 things proper arrays because that's the type that I specified. So basically the tuple syntax doesn't always mean tuple. It can also mean other stuff. It's the same similar concept as with structs. So if I have const point equals struct A usize B usize, then I can do const P equals point B equals 2. So that works. Or you can also do this. So this is anonymous struct syntax, right? The only difference is that here we are naming keys. Here we are not naming any keys because they are implicitly put in the comp time tuple. But basically this is like a syntax where the type is implicit and it gets inferred by the context. So in this case, because it's a point that we're trying to make, and it works also with arguments for functions. So for example, general purpose allocator takes an empty tuple. But that's not exactly an empty tuple, I think. I think that general purpose allocator takes a configuration struct, and what we are saying is that we are fine with the default value for the configuration struct. Some other functions instead want proper tuples. So for example, print wants a tuple of elements, and it's fine that those are known at comp time, like the structure is known at comp time, because print behind the scenes use FMT, which is a somewhat complicated comp time function that basically parses the string here and uses these placeholders to understand how many items should be in here, etc., etc. So the point is, this dot curly brace syntax is a bit interchangeable in meaning, and you need to be aware that you can use something can be the default value of a struct that you don't even care about the name of. In other contexts is a proper tuple used to do basically variadic functions. In some other times, it looks like a tuple. Also, here, since we are not specifying anything, it's empty, so you cannot distinguish. You don't know if it's like the syntax for a struct or for a tuple, and it could be both. But I think that this would otherwise have to be something like dot I don't know, safety or whatever the options are, and then you set it to false. So at this point, you know that this is actually supposed to be a struct, while when there are no key names, you know it's a tuple. But the point is that tuples can be proper content tuples, or they can be coerced also to arrays, which is what's happening here. So this is a normal for loop that has where all the types are homogeneous because these are slices. And it's interesting because this works because these are slices, but if like those were strings, like if you had arrays of different length, you could not be able to do this. All the types need to be homogeneous for you to be able to make a slice of this stuff. In any case, this is like a interestingly implicit side of Zig syntax. I think it's fair because like struct, pointers, and arrays are like the three things that you do all the time when programming, and so having shorthands for those symbols is fine. But yeah, it's something to be aware of, and maybe not obvious, because if you come from a fully, like if you come from C, in C you cannot do comp time stuff this way. I think C has anonymous struct literals, but that's it. And if you come from a higher level language, you think that you can do this stuff whenever you want this. But no, like this is a problem. You have to understand that this is a problem type. If you like, you cannot think of this easily as something that you can iterate on in a statically typed language. And it's not just a limitation of the language, it's something you don't want to do because this has problematic properties. Okay, what is in the future of Zig in your opinion? Is it embedded development? Array of enlightenment. In the future of Zig, I think the future of Zig is any application that needs to not suck. So embedded, I guess, is a good example because Zig doesn't assume that you always have a heap, etc., etc. But also, I don't know. So the other day I was rendering a video. I was using DaVinci Studio. I was rendering a video, a 4K video, and DaVinci was like eating all my RAM. I have 32 gigabytes of RAM, and DaVinci was eating all of it basically, or all the available RAM. But DaVinci, since it's an application that's memory hungry, I guess it understands that it can only eat memory up to a certain point, and then it has to make do with whatever memory is available. It does crash from time to time, but it understands that there's a limit to how much memory it can get, and that's it. So as DaVinci was rendering, I alt-tab to Firefox, and the moment I do this, Firefox crashes and Discord crashes. Why? Because Firefox and Discord were running. I had a bunch of tabs open, so at the very least, Firefox was running JavaScript code, and Discord also, the desktop client, was running JavaScript code, and JavaScript code allocates memory. And when JavaScript code cannot allocate memory, and in JavaScript you allocate basically all the time, and if your JavaScript code cannot allocate memory, there is no escape hatch. Like when you write JavaScript code, you never have a way of saying, I try to make this object, I try to make this array, and if I can't, I'll try to do something else. So when that fails, the only option left to the application is to crash. So at this point, the question is, maybe given past and current trends, you don't think that a systems programming language is worth the effort when writing an application, like a desktop application? But do you want your applications to crash whenever you're rendering something? I don't want that. So I'm not saying that thanks to Zig tomorrow everybody will make good software. It's not gonna happen. People are still gonna use Electron and whatever. But I think that until recent times with like Go, well, Go doesn't allow you to handle memory either. So let me take that back. Let's say until recent times with Rust and Zig, your only options were what? C and C++, and I don't know, they don't seem great, or rather, maybe it's not strictly the language, but like the language plus the ecosystem doesn't seem great. I wouldn't feel comfortable writing a desktop application in C++. I wouldn't be happy. But with Zig, it's more reasonable and you can do it. So for the future of Zig, I really hope that it's also going to be... Zig in general is supposed to be general purpose, so the design of the language is not tied to embedded, it's not strictly tied to hardcore systems programming. Because the reality is that handling memory allocation failures is something that I think everybody wants to do past a certain quality, a certain threshold of quality that you want to achieve. For desktop applications, for embedded, I would even argue that the same applies also to even distributed systems. If you're writing an app today and you put it in a container and you put it on Kubernetes, you need to size the application and you need to know how much memory is going to consume, and Kubernetes is going to, like, if you have an application that consumes 2 gigs of RAM and the virtual machine has 4 gigs of RAM, let's ignore the OS for a moment. Then Kubernetes knows that it can put 2 instances of your application in there. But the problem is that application memory use is not stable, right? With heap allocation, it goes up and down. And so if you go up and down a lot, your application is not nice to have to orchestrate, because at one point it will run out of memory and it will crash. Kubernetes is going to restart it, and it's not the end of the world, but still, it's not great either. So I think that there are a lot of contexts where having precise programming tools, a precise programming language, can help you if the ecosystem doesn't suck too much. That's my general impression. So I hope to see Zig in a bunch of places, even just because of that. As long as Zig, Rust, name, etc. contains panic abort assert that can be called at any point instead of returning a result or error, it won't be crash safe. I don't care about the program being crash safe. Crash safe doesn't mean anything. Like, crash safe, Aukras, take a moment to think about how meaningless the word crash safe is. Crash safe is a known concept. You crash because this was a occurrence that you didn't account for in your programming language. So there is no programming language that can automagically make everything crash safe. The only option is for you to properly handle the failure. So yes, programmers will always have to design this ourselves, and not everybody will do it. But the problem is that until recently, if you were using something like Python or JavaScript, you didn't have the option. Even today, if you use today something like Python or JavaScript, you don't have the option of non-crashing. It doesn't exist. Even if you are willing to put in the work, you cannot do it. It will crash, period, without your ability to control it. But if you use Zig, Rust, or I guess NIM without the GC, if you do that, then at least you have the opportunity. And will everybody do it? No, but some people will. So like DaVinci, for example, is nice when it comes to memory because it's important for its domain. I think that there are other programs that can do it. But at the same time, I understand why people don't want to do it today. Like, I can tell you that I'm willing to go through this effort when writing Z code, but I would not be willing to go through this effort if I was using something like C++. I think this is an important difference, and it's not really a matter of, so it's not a matter of enforcing something like in the style of like crash safety or memory safety. The point is allowing people to have the opportunity of doing it and reducing the friction to be able to do it. And at that point, I think that some improvement will happen. It's not going to be global, but at least people will have an opportunity to do it. And I think that good software is something that we are increasingly in need of, because software that we are getting from big tech is increasingly getting worse and worse. So at one point, I think that if you make it easy enough and they make software that sucks enough, and boy do they make software that sucks, Even software that is supposed to be good, like Firefox, I'm sorry, I'm a Firefox hater because I would like to like it, but I can't. It sucks. And so at one point I think that scale will tip on the other end. We'll see what happens. I would be happy to pay, by the way, for a browser that doesn't suck. I used to like Opera in the old days. I don't know if there's anybody here who's seems weird to say, but old enough to remember Opera. Even from the days when Opera had a ad banner in the top bar, which is disgusting by modern standards. It wasn't super nice even at the time, but Opera was so nice as a browser. It was by far my favorite browser, and now Opera doesn't exist anymore. There's Vivaldi, I think, but I haven't really tried it yet. And in any case, I think the spirit of the old Opera is long dead. Also, Opera was the browser that invented basically proper zooming. Like, it used to be that browsers, whenever you zoomed, they would just increase font size. They wouldn't be able to change the geometry of the page. And Opera was the first browser that was actually able to change the geometry of the page to account for the extra zoom. Sorry, I'm a old man when it comes to browsers, I guess. In any case, I hope to see that. I think that allowing people more creative space is more important than chaining them in a something safe language. I also think that. Okay, I think that's it. So thank you everyone.